It's space weather. Weather all comes from outer space. The space weather. Earth is a cosmogenic place. The space weather. Alright, since we have 20 tabs open here, we better get to it. Looking at the sun at 171 angstroms. Sunspot 2730 has formed into existence, high off the equator and followed by another plage. Let's look at the magnetogram. Hey, that ain't the magnetogram. There we go. There you go. It's a sunspot. It's got two fields. It's followed by more active regions. Check it out. Sunspot 2730. Here's your intensity gram. Sunspot is not big, but it's high off the equator. We'll explain the relevance of that later. And here are your magnetic lines. We're looking at 335 angstroms here. North portion of the sun is pretty dense. South portion of the sun is pretty diffuse. Taking a look at the 304 angstroms view, you can see plasma filaments all around the edge of the disk. Giant, towering, dense one right there. Also reflected in the 171 angstroms view. One down here. Some movement up here. And let's look at the latest earthquakes. We have another earthquake we didn't enjoy too much at the South Sandwich Islands. It's a 7.1, downgraded by the U.S. Downgrade Service. Originally listed as a 7.3. We won't go to the tab, but no tsunami warning predicted on this. Largest earthquake in quite a while. Hopefully didn't cause a lot of damage, but it was at depth. So that area remains on alert for a 7+ magnitude earthquake. Take a look at spaceweathernews.com. Look at some other solar details here. See a little bit of X-ray fluxing. Nothing even in the B-class range there. Probably associated with the birth of Sunspot 2730. Let's look at the real-time solar wind. So, the BTBZ is bouncing around in the last few hours. No significant signal on the phi angle, indicating no significant sun-to-earth magnetic connection. 4.73 protons per cubic centimeter is the solar wind density. Pretty much staying level there. And we've lost a little bit of solar wind speed at 564 kilometers per second. The coronal hole wind stream continues. By the way, if you like the music in our videos, please visit our music page at soundclick.com/GoldenCat Productions. You can get some of the tracks here. And by the way, Unified Theory 3 really is titled Regarding Physics. We would like a unified theory. Now, let's head to some articles on phys.org. Let's start out with some nonsense. Humans may be reversing the climate clock by 50 million years. Apparently, some top-level global warming alarmists seem to think that human CO2 emissions are going to entirely melt the Antarctic glaciers. So, Antarctica formed about 33 million years ago, when the Earth was about 3 degrees Celsius warmer than it is now. This brilliant article is talking about how by 2150, we could resemble the mid-Pliocene, going back more than 3 million years in geologic time. Blah, blah, blah. I don't know what they're talking about. However, I did read the article all the way through. I mean, really, we don't even know what the hell they're talking about in here. Apparently, they're saying that the continents were packed more closely together. Okay, fine. Global temperatures averaged 13 degrees Celsius warmer than they are today, which isn't right. I don't know what they're talking about. Also, interestingly, these idiotic models that they come up with this stuff do not include solar forcing. And so it is complete nonsensical bunk, garbage, BS, crap based on the IPCC 5, which does not include solar forcing. So we'll leave links to the article. Feel free to go there and comment and tell those people how stupid they are. Next, let's talk about the Voyager 2 probe. Voyager 2 probe has recently entered interstellar space. You see, as the sun spews out plasma, you've got your solar system in here, right? There's your solar system. And then you've got the termination shock. And then you got the heliopause. Heliopause is where there's no more solar plasma. Now, Voyager 1's instrument to measure this died before it made it to there, years before it made it to there. Voyager 2's instrument is still working, and it sent back data indicating that it hit the heliopause. We'll leave links to that article too. You see right there, boom, the cosmic rays go up. The solar plasma goes down at the same time. Perfect. November 5th, 2018. So we've got it. There's the 3 different instruments that are sending back the plasma currents. Fantastic. Should get some great science out of that. Here's another interesting article on phys.org. It's really just about the different methods used to track the same sunspots, the way they're counted, and so on. Basically, it's just about the fact that different telescopes and different instruments get a different view of what they're really seeing there. So read that article, nothing too exciting. And while perusing articles, we noticed another idiotic article on Universe Today. If you'd like to lose IQ points, please read this article too. Super brilliant. Basically what the article is saying is that the end of the Eocene... Wait. Pardon me, I don't have my geologic epochs memorized very well. So yeah, the Permian-Triassic extinction event, known as the Great Dying, where up to 70% of terrestrial vertebrates and up to 96% of all marine species were extinguished during the Great Dying. How did it happen? Could it happen again? Apparently, these, quote, scientists, end quote, are talking about anthropogenic climate change as well as volcanoes making the planet warmer. Now, we know for a fact that Pinatubo and Krakatoa made the whole planet colder for over a year in the case of Krakatoa. Yet this stupid, idiotic article is talking about how maybe a volcano made the planet so warm that it killed off all those species. Anyway, again, read that if you feel like losing an IQ point. Now let's look at an article on No Trick Zone, which is a site dedicated to debunking nonsensical climate science. Apparently, as of January 28th of last year, there are 133 papers linking solar forcing to climate change. Yeah. So we've said it here over and over again. The sun controls the Earth's weather, and more importantly, the Earth's atmosphere is a crappy measurement of how warm the planet is. The Earth's thermal capacity lies in the oceans, not in the atmosphere. About 0.1% of the Earth's thermal capacity lies in the atmosphere. As far as how hot or cold the planet is, what I really challenge you is, what's the temperature of this water right here at 5 meters depth? See that water there in the Indian Ocean? What's the temperature of it at 5 meters depth? You don't know? Right. Nobody knows. Because it's not being measured. You can't measure it with a satellite. We don't have buoys that are sufficiently doing it. We don't know the temperature of the water in the Indian Ocean. Only a tiny percent of thermal capacity lies in the atmosphere. The latent heat of water is massive. The latent heat of air is tiny. That's why the weather can change so suddenly. Speaking of weather changing suddenly, the reason the jet stream is so jacked up is because of the magnetic field. Here's your 250 millibar wind streamlines. And you can see in the southern hemisphere, you've got double jet streams. You've got jet streams breaking up, getting sucked up to Alaska. Concentrations of jet streams. This is your meridional jet stream flow. And this is the GFS model, by the way. This is where it just was. This is where it is. This is where it is now. And this is the GFS forecast of where it's going. You know, the jet stream is normally like this. It's usually not like this. Now let's talk about sunspot cycles. We have had some questions in the comments section on the channel and on our Minds.com page. By the way, if you don't have a Minds account, head to Minds.com/Smashomash. Check out our page there. And what are we talking about? Well, we're talking about the butterfly diagram. What's the butterfly diagram? Well, we're going to explain it. So, sunspot cycles are characterized by the polarity of the sunspots. And as you can see, this is what we call the butterfly diagram, because one way to know what's going on with the sunspots and the solar cycles is this diagram up here. See this spot up top? What happens is when a new cycle begins, the sunspots appear far off the equator. Here's the solar equator. Most sunspots, are going to show up between 30 north and 30 south. When a new cycle begins, sunspots start appearing high off the equator and at reverse polarity. See that? As the cycle comes to an end, they get closer and closer to the equator and less. And then there's a slight overlap while the next cycle kicks in. Now, you can clearly see from this diagram that 1960 was the solar maximum, the most recent solar maximum. Cycle 19, look at the bottom. Cycle 19 is a lot beefier than any of the previous cycles, including 23, including 22. So, what does it mean? Also, I'd like to make a quick note of the fact that look at this extended cycle. That's not a good sign. That is a sign of the magnetic dynamos going out of phase. And basically, we're just waiting for the rest of this part of the graph to get filled in. I hope that helps to understand the solar cycles, sunspot location and polarity, and when cycles begin and end. By the way, also, we should probably also note that you don't really know when the new cycle has started until a bit after it started. It's not like one day you wake up and poof, it's a new cycle. So you're going to start to see reverse polarity sunspots. You're going to start seeing sunspots that are high off the equator. And that's going to be an indication that we're getting sunspots from the new cycle. So yeah, there's a diagram. We'll leave a link to that also. Thanks for watching. Let's watch that sunspot form. Thank you, subscribers. And, hey, everybody. Please help us get to 1,000. We're amazed that we got to 100, much less 200, much less 500, much less 700. So share our posts on your social media, you know, tell your friends about space weather, and tune in tomorrow because we'll be doing it all over again. Remember, when you're naming sunspots, name them 2723, and if you drink, don't drive.